group, Group 11 will present about supply chain optimization and network design for Nestlé Vietnam. Here's our team members. This is a content overview. First one is introduction. So the company we choose is Nestlé, which is a food and beverage corporation, and the product focus on here is Nescafe. Next one is objective of the study, as can be shown on the slide.
So this is our current supply chain overview, and these are the diagram of supply chain of Nestlé. So the supply chain of Nestlé in Vietnam is a highly integrated design, not only for efficiency but also a core enabler to companies creating shared value strategy. So let's break down this supply chain. As for the upstream is the Sustainable Sourcing Foundations, farm Nestlé, Nescafe plant, and farm the auxiliary supplier providing us cans, bags, and printing services. So moving on to the midstream is the integrated production and centralized distribution. We have a production in Nestlé Vietnam factory. It's located in Trị An factory, and as for the distribution centers, it's located from northern to southern of Vietnam also. So moving on to the last is the downstream. We have 5 main markets here. As you can see it on the slide, the first is an exportation over 25 global markets. The second is e-commerce. The third is online website. The fourth is retailer, and the last one is wholesalers. So let's moving on to the key activities here. The first is a focus on sustainability and quality in upstream. We have a sustainable recruitment from Nescafe plant and quality-driven production, commitment to net zero by 2050. So in midstream, we focus on efficiency, sustainability, and technologies, as in the warehousing and logistics. So as for the supply chain triangle, we have 3 aspects here: is cost, service, and assets. So as for the trade-off, the first trade-off is between the cost versus the service, because if we superior the service, it leads to the problem that we're gonna have a very higher cost. Moving on to the next trade-off is between the service versus the assets. If we guarantee the product is viable anytime, it's gonna require a huge higher assets, because we have to prepare a lot of inventory to this challenge.
So let's work out the current fitness of the Nestlé. So we have 5 problems here. So with the first one, we have a complex and high cost distribution network. The next one is inaccurate costing and unbalanced production planning. The third one, we have inventory management. The next one, low visibility and poor suppliers coordinations. And the last one, we have sustainability and pricing alignment. So with the framework of this one, we have figure of the report, and this leads to lack of control visibility. Only 1.5 million stores are directly monitored, and this is high supply chains are physically difficult and inaccurate reverse tracing during recall. So with this domestic reverse logistics and high cost break, which is lead to significant brand reputation damage and market share erosions. So this one, by the way, we apply CPM finding. By the way, analyze show critical path activities was internal logistic tasks in order to we unless to optimize the forward logistic become high cost and inefficient. When forced into the reverse logistic, it is curriculum want to resolve easy lack of transparency, limited internal logistic capacity, and high transportation cost. In order to do this one, this is improving record and reverse supply chain efficiency. Is estimating total record time after every collection and middle outlets to find distribution by the way you apply the utilize PE or TCBM. So this is the role of the CBM, and so we have the record stock distribution in the table. And why this is so important? Because it helps us to identify time-sensitive tasks, allocate framework capacity, plan consolidation and routing, and the last one produce in a feasible recovery timeline. And as you can see, we have 2 nice steps in the critical path. So in this one, in each activity, we label in the APC alphabets and after we please disasters in estimation time in each activity. And so we planning supply chain network and processing optimization time in the beginning with early stage, early finish, plus the start and last finish. So we continue to do this one we have the result we can the minimum possible time to complete the record process, and this activity directly determine the project duration and cannot be delayed with the half zero split. This is the critical path we need it. So the result we get, we have more control and confidence, and we try to reduce limited capacity, slow scale up, and in others, seeing we more flexibility, high capacity, faster recall, and less control. So this is the final report and quarterly report in 2015. In this case, And this incident not only impact the company but also reduce sales the others. So the large multinational firms may survive such disruptions. Small company could face several consequences, and a major recall without sufficient financial resources could even drive them into bankrupt. And by the way, we use the recall path to try to reduce this one.
Well, best forecast herd production inventory with it that they had built up and down. Reading too high means excess stock and reading too low means shortage. Operational disconnect. Team didn't trust the data, so they just reacted. Plans were useless before they were finished. System failure. They failed to match supply with demand. It wasn't just a math error. The whole system was broken. APA planning matched production to demand over 3 to 18 months. Their goal is simple: meet demand at the lowest cost while keeping operation stable. They use a monthly rolling plan. They update it with constantly with new market data. They also balance the workload, so no single factory is overwhelmed. However, the current system has three big problems. The first one is high overtime costs. The second one bottlenecks, and the last one is stock imbalance. To fix it, we build a mathematical operational model, optimization model. It calculates the best production and workforce plan for each month. First, the input, we fit the model our forecast demand, factory capacity, and own specific costs for production and inventory. Next, the output. The models tell us exactly how much to reduce, how much to overtime to do, and what our inventory level should be. The heart of the model is the objective function. We want to minimize the total cost of production, overtime, inventory, and vanity combined. The model must follow rule called contrast. The first rule is capacity. They cannot reduce more than their factory allows. Regular production must stay at the limit CT, and overtime must stay under the limit OT. Second is inventory balance. This ensures the flow here. Also, a number must be positive. They cannot reduce negative amount. Well, the model here find the best balance to minimize the total cost. Next, the model cover the first half of the year, starting with a 15-ton sexy stock and zero backlog. Globally, the stock out vanity is set at 410 base point because losing stock means losing market share. To handle the summer demand spike in March and April exceeding their standard capacity, they use the flexible overtime. They use their simulation model to find the optimal pricing strategy that strictly allow their factory reduction limits. Here is the detailed input data table used for our simulation. And the results show that by adjusting price dynamically, we maximize revenue while ensuring demand never exceeds our supply capacity. We rebuild up inventory in early period to satisfy period 3 by without using overtime. And next, we target overtime during peak to achieve a perfect 100% service level. In short, this approach saves money and ensures consistent supply. Let's look at why their forecasting failed before 2014. They relied too much on human judgment. 80% of forecasts were manual, while only 20% used data. This caused a huge bias. Teams couldn't agree on the number. Also, that old tools were too slow to keep up with the market. And next, current monthly updates are too slow and prone to human bias. Smaller model failed during promotion. Retracement worked better because it tracked real tribal-like price and marketing instead of just looking at the history. They propose an AI tribal demand sensing using real-time data like POS and weather. They detect trends instantly instead of waiting for demand end. The shift target is 50 to 20% reduction in forecast error. Less error means lower cost, optimized inventory, and try to move from reactive to proactive planning.
So moving on to the next problem is inventory planning and management. This begins with the core issue is the complexity of a multi-stocking keeping unit portfolio. This creates three major problems. First, you can see it's a long tail effect. Second is forecast inaccuracy, and finally is warehouse complexity. So the consequence of this is a very costly imbalance. It's like two sides of the same coin. On one side we have stock out, and on the other side we have overstocks. So how does Nestlé currently manage the inventory? So their current practice of this is centralized distribution centers, and their limitation of this approach is reactive to safety stock policy and seasonal build-up.
Next is inventory model to address inventory challenge. First one is EOQ for high velocity, stable demand stock keeping units. This is applied to Nescafé Cola, powdered milk, and popular beverage to optimize all the size, reduce holding costs, and avoid overstock. Next is news vendor for long tail and seasonal stock keeping unit. It's applied to limit edition flavor, small volume format, and seasonal products such as gift sets to balance overstocking and understocking. Last one is continuous review for high quality stock keeping unit. Is suitable for highly volatile beverage stock keeping unit to respond quickly to demand spike and prevent stock outs. The optimization proposal focuses on two core solutions. The first one is implementing dynamic static stock. Static stock needs to be adjusted in time, and the real-time demand visibilities need to connect directly to point-of-sale data, such as Copmart and Vmark. This improvement will have Nestlé increase inventory turnover, reduce stock end rate, and decrease expired product loss.
So with it, the final issue in this one, we have the background. The Nestlé Transport Network in Europe was historically decentralized with its country managing its holistic, its create fragment system, inconsistent process, and no unified framework management. So this leads to problems through lack of visibility and coordinations became major constraints. And you can see this key problem with lack of end-to-end framework visibility, poor coordinations with career and vulnerable during disruptions such as COVID-19 period. And in this one, this also impacts on operational, unreliable ETAs, warehouse scheduling problems, as well as in the financial impact. This is higher cost in the fragments, and as well as in customer service impact and strategy sustainability impact, with a huge damage in the supply chain management. So in this one, we have the table to describe the impact in each metric and this situation before, and this cause the mentionable, and this is cost reduce efficiency and harm service reliability. So that's one we implementing the cross-functional visibility last form of the way you implement the transport visibility hub as a unified real-time tracking system for your transport operation, as well as become a shared interface connecting procurement, transport operation, customer service, sustainability, and planning. And this is predictive ETAs, live shipping tracking, exception focus dashboard, and as well as impact on environment sections. And this is we have again the result. And by the way, you apply this one. We have higher OTIF and fewer place deliveries in service reliabilities. Also reduce manual workflow, faster reaction time in exception handling, standardized data enabled more strategic sourcing, and also sustainability reporting, operational stability. So, by the way, we are seeing the decision in supply chains, career interaction shift from fragment and transparent performance data, and also relation involved from the transactional to the strategic partnership supported by shared visibility and aligned service expectation. This is redefining career collaborations, and the result of this one is more resilience, agile, and sustainable transport network.
Well, sustainability costs are high, yes, prices must stay low. This increases their profit margin. Their current approach is compliance. They use satellite audits to track deforestation. It's worth, but it's expensive because Nestlé pay the fuel alone. To solve this, they need strategic alignment. They can use intentional contracts to share the burden. Don't you product segmentation, leading premium line absorb costs while keeping mass market good affordable. In summary, they are evolving. They are shifting from a compliant-focused model to a value-driven model. It turns sustainability from a cost burden into a strategic competitive advantage. Currently, Nestlé uses market-based pricing with frequent promotion. While this drive volume, it creates two big problems. The first one is price wars, and the second one, operational chaos. They propose dynamic pricing to maximize revenue by strictly aligning prices with their available capacity. This strategy boosts fortunes, stabilize operations, and improve forecast accuracy. Now let's compare their transport management methods. The old ways were decentralized, and the new way is centralized and visible. Looking at the comparison, governance, they moved from local autonomy to regional standard, visibility from manual updates to predictive real-time tracking, and resilience from slow reaction to rapid data-driven responses. In conclusion, they have evolved from a fragmented manual system to a smart centralized network. This new method improves their efficiency, cut costs, and make their supply chain much more resilient.
So last section is a discussion between the trade-off and decision balance. So as for the first problem, our solution is implement differentiate inventory policies. And this trade-off, that means that we prioritize asset efficiency over absolute service uniformity. So as for the second trade-off is between the fixed assets and variable costs. These managing the fixed assets like trucks and especially during a crisis, our solution is to outsource peak demand to third-party partners. And this trade-off means that we shift from a high fixed cost structure to a variable cost models. So in conclusion, our entire strategy can be summarized by one core shift is moving from reactive to proactive. And this ensures that every trade-off that we make is deliberate economic calculation to maximize the value for the whole company. So this is the end of our presentation, and these are the reference of our project. So thanks for listening.